Hello everyone, this is group 4. We are going to talk about Docker today. So our group members are Summi, Mung, Arun, and me. My name is Gökhan. So this is the content of who is going to talk about Docker. And so I'm starting with introduction and overview of Docker. So mobile apps are software applications designed to run on mobile devices, such as cell phones and smartwatches. Moreover, for most of the applications, smart devices require internet. Applications emerged in the early days for easy access to emails, to create a calendar and phone book. However, over time, they have been developed in direct proportion to the needs of people. For example, nowadays, you can order food or clothes, watch TV live, or play games online through apps. Docker makes it possible to separate applications so that they can deliver quickly. It is also an implemented platform to run, develop, and ship them. Docker's functionally problems, areas for improvement, and benefits are also described in general terms in this report. So overview of Docker is important to understand concept of container before dividing into the use of Docker and its benefits. According to Google, container is a set of software that contain everything needed to run in any environment. In other words, containers are the answer to the problems when the software seamlessly runs from one environment to another. So please switch the slides for me. There are many reasons why Docker has become the most popular container platform among developers. First, there is less duplication. When developers run extra virtual machines, CPU and memory get duplicated, and it causes the resources to run out quickly. Second, multiple versions of the application can be run without extra enormous configurations. Also, since Docker is an open source platform, anyone can contribute and build new features. With Docker, developers can put their all time and resources into coding without worrying about which system it needs to run on. Furthermore, Docker containers run without any configuration in a client environment. Also, there are thousands of shared libraries that developers can use. Compared to traditional virtual machines, Docker containers are fast to create, deploy, and run. Another major advantage of Docker is scalability and flexibility. Developers can do upgrades and repairs without taking down an application. It is worth noting that leading information technology companies like Amazon, Microsoft, and Google are supporting Docker in their various services. Now we are going to talk about the background of the issue. Summi is with you.
Hi everyone, my name is Summi, but it's fine if you just call me Summi. Totally appreciate it. And I'll be talking about the background to the issue. Now, talking about the background to the issue is how did Docker come about? How did we get to start using Docker? Now, the idea of using Docker is, as my colleague Gökhan has said, basically it started about having applications, building applications and having them work on different devices. But the problem here is, initially, prior to when Docker was created, software developers wanted to create applications. And when you create applications, when you create different programs and different designs, you want this program, you want these designs to run on different devices. You want them to run on different operating systems. You want it to run on a Linux system, the same way it's going to run on a Mac OS, the same way it's also going to work on a Windows OS. So you wanted to create just one program that would work conveniently on all of these operating systems. Now, prior to Docker, software developers use technology as application virtualization to package computer programs. Now, what application virtualization does is when a developer writes a program, it writes a program, say, using a Linux OS. At the end of the day, after you've written this program using a Linux OS, you want to use this same program and say, oh, I've designed an application, I want to try to run it on a Windows system and see if it's going to operate successfully the same way it's running on a Linux OS, or you want to try to run it on a Mac OS and see if it's going to run successfully. Now, what the application visualization does is it encapsulates the whole program or the program written for that particular application. And application visualization encapsulates the whole program on that operating system and enables it to work successfully on another device that's on another operating system without having to install this program. Now, this enables the application to work successfully without any issues. You can design an application on Windows OS and use it successfully on Mac OS. But the problem with this application visualization technique was the fact that it required the whole OS of the new system to be visualized as well as the server. So if you are going to design an app on Windows OS and you need to use it on a Mac OS, it means you need to create a virtual Mac OS, an entire virtual Mac operating system, as well as the server. You need to create a virtual one separately, which was beginning to be a whole lot of problem and was quite taxing for the servers and the systems generally. Then this was what brought about Docker. Now, why the problem still persists was also because Docker as an why the problem also persists is because the application virtualization technique uses the monolithic architecture as compared to the microservice architecture. What the monolithic architecture does is it takes the whole program design and puts everything just in one package known as a container, just like my colleague has earlier explained. It takes everything you've designed and puts into one container. And then this container is what is then moved to another system, which is virtualized. But this was a whole lot of problem, because imagine having everything put into one container means whatever happens to that single container affects the whole program. And this was beginning to be a burden, was beginning to be a whole lot of problem for developers. And then what the monolithic architecture does is, monolithic architecture is not scalable, it's quite stressful, and it's quite taxing for developers to use. Then the Docker technology came on board. And when Docker came on board, Docker uses the microservice architecture. With the microservice architecture, what it does is the different services rendered by a computer program is splitted into different packages and put into different containers. Meaning, if you design an application where a user is going to make payments, a user is going to add friends, a user is going to be able to send messages. What the Docker does using the microservice architecture is that it takes all these different features and put into different containers and put into different containers, and then transport them to the new OS on which it wants to be used in different containers. Meaning, if there's ever an issue with either of these programs, all it needs to do is look for the target container where there is an issue and fix that issue without having to affect the other containers, which was more of a great advantage to Docker. Now, this was where the background issue came from, the fact that developers could not break down what they needed to do, and it was quite taxing for them to convert an entire OS just because they want to make an application work on another system. Instead of me, rather than going further into this, I would let my colleague Aaron talk about the Docker as an application itself. And thank you very much, guys.
Hello. So there are many, we found many findings and recommendations about the Docker. So one of the things we found is that difficult to compute the change, and also it's very difficult to adapt to the change. And we also found that it is a very single service architecture, and but it can be used in the lightweight containers like Dockers. So and
sorry,
also
we can't see you. There's a picture here.
I think. Hello, I'm going to talk about the findings and recommendations here. So one of the things we found is it's very difficult to compute the change in Dockers, and also most of the containers are single service architecture and also used in the lightweight containers. But Dockers give this many service like the programs and bugs to finish for the developers. And another thing is it is open source performing inside the containers. So Dockers are basically a predefined program, so we can use it in any environment irrespective of bugs and viruses, because it can adapt and change it. And Docker is also very fast compared to the other service because of its hardware and software are virtualized. Thank you.
Hi guys, now we have come to the conclusion part. So basically the Docker is a tool that develop, ship and run applications by using containers. Okay, so more applications can run at the same time. And also with the Docker, it's easy to create and run applications without changing or configuring the environment or operating system. It's also easy to manage and do repairs like bug fixes without halting entire application. Containers are more portable and efficient, and it's Docker is getting more like popular due to the like organizations shift to cloud native development. Like Docker is partnering with the like information technology giant companies like Google, Amazon, and Microsoft, and so on. Like even though Docker has many advantages, there are like some issues need to be addressed. So when it comes to security, it's not 100% guaranteed. And if you store lots of like valuable data, and Docker is not recommended amongst the software developers. And also it's getting complex due to the new technologies. And also Docker is not good for application that requires the rich interfaces, that Docker can't handle it. So also, since it's an open source platform and there is no guaranteed guide, so if you are using Docker and you're stuck on something, and the thing is you need to figure out yourself. So that's the downside of the Docker. So basically, okay, so here we have come to the reference page. And that's all for our presentation, and thank you for your attention, guys. And if you have any questions, and we are more than happy to answer your any concerns or questions. Thank you.